Welcome! This tutorial is for new users of QUCS, Quite Universal Circuit Simulator.
There is a companion tutorial exploring the electronics of this RC low-pass filter. This tutorial creates the simulation project in QUCS.
We're going to draw the entire schematic and specify an AC steady-state frequency domain simulation. We'll plot the magnitude of the output voltage across the capacitor. We'll also plot the phase of the output voltage. We'll specify some equations needed for the dB and phase quantities that we'll plot. We'll also plot the current on a linear scale, as well as plot the current on a dB magnitude scale with the phase on the right-hand vertical axis. Let's open a new project and start. To access the components that we want, we're going to go in the main dock and then Components, and from the pull-down we'll choose Sources. We can drag an AC voltage source onto our schematic and then right-click to edit the properties. We'll change the name to VN. To access the lumped components, we go back to the main dock, choose Lumped Components, click on the resistor. We can place it on the schematic and then hit the Escape key to end the placement mode. For the capacitor, before we place it, we can right-click to rotate it. We hit the Escape key to clear the placement mode. Now for the wires, we go to the top of the graphical user interface, select Wire. We click to start the wire. We can click for corners, click to connect the wire, click to start, click for a corner, click to end. When we're finished, we hit the Escape key once to finish that draw, and then hit the Escape key again to finish the drawing mode. We need to put in a ground. We can get that from the top of the graphical user interface. Let's also change the value of our capacitor. Right-click to edit properties. We'll change it from 1 picofarad to 1 nanofarad.
Now what if we don't see this main dock on the screen? Or what if we inadvertently closed it? You can get the main dock back by going to the View pull-down and choosing Dock Window.
We can also put in some node names with wire labels. From the top of the graphical user interface, we choose Wire Label, and then we click on the node and we enter the name. We hit the Escape key to clear the wire label mode, but notice we can also access the ground and the wire label from the Insert pull-down. We'll put a wire label on the output as well, call it Vout. Next, let's place an AC simulation. To access the simulations, we go to the main dock and we select Simulations. We can drag an AC simulation over to our schematic. right-click to edit properties. We want logarithmic for the x-axis, a log frequency scale. We'll start the simulation at 10 kilohertz. We'll end the simulation at 10 gigahertz. Let's choose 50 points per decade. Next, let's insert an equation. We hit Escape to clear the equation mode. Right-click on the equation to edit the properties. The first quantity that we want to define is the output voltage in a dB scale. We hit the Apply button to overwrite that default equation of y equals 1. Next, let's specify the output voltage phase. Now we'll hit the Add button to add that equation to our list. Next, we'll specify the dB magnitude of the current in the loop. Notice that the current we're using is the current through the voltage source Vin. We hit the Add button to add it to our list. And finally, we want to specify the phase of the current in the loop. We can zoom out and rearrange our schematic a little bit. We hit Escape to clear the zoom mode. Now's a good time to save the project. Now we can run the simulation by going up to this gear-looking icon at the top of the graphical user interface. Notice that when the simulation finishes, we get a blank screen for the plots. We're going to cancel that window, and instead we're going to put the plots on our schematic. Notice how QUICS has, in the main dock, set us into the Diagrams tab. We can drag a Cartesian plot onto our schematic, and the first quantity that we want to plot is the dB voltage output. This is the one that we defined. With properties, we want to label the x-axis as frequency. We want to set it to logarithmic because we're using a log frequency scale. The left vertical axis is V out in dB. We can select the graph and stretch it to make it larger. We need to go to this arrow to invoke select, click to select, drag the corner, then click to deselect it. For the next plot, we can copy the first one. We select it, right-click, copy it, and then right-click to paste and put it right next to it. We hit Escape to clear the paste mode, then right-click to edit the properties. For this signal, we'll take the current, Vin.I, this is not the one we defined, it has the same frequency axis, of course. The left vertical axis is current on a linear scale. Let's zoom out so we can place some more plots below. Let's copy our first graph again and paste it down below and another one to the right. Hit Escape to clear the paste mode, then right-click to edit properties. For this plot, we want the phase of our output voltage. And this time, let's make the thickness of it 3 to make the line more visible. For the left vertical axis label, it'll be Vout phase. And for the last graph, we'll right-click to edit properties, and we'll place 2 different signals on this graph. First, we'll place the dB magnitude of the current. This is the one that we defined. Next, we'll place the phase of the current. We'll change the thickness to 3 for the phase, as well as for the magnitude. We'll change the color of the phase so that they're different. We'll go to Properties. The left axis vertical label will be current in dB, and the right axis label will be current phase. The last thing we need to do is to put the phase on the right axis. So now we've got our schematic with 2 voltage labels. We have an AC simulation and an equation defining 4 quantities. And for plots, we've got the dB magnitude of voltage out. On the right, we've got the current on a linear scale. On the lower left, we've got the phase of the output voltage across the capacitor. And in the lower right, we've got both the magnitude of the current in dB and also the phase of the current through the loop.
Here is a visual summary of where we accessed schematic components, simulations, and plot diagrams. Wires, ground, and equations came from the top toolbar. They are also available from the Insert pull-down.
The Quick Simulator is free. This is the end of our tutorial. We hope it has been useful to you.
Thank you for watching and learning with us.